أعزائي الطلبة والطالبات، أهلا وسهلا بكم. النهاردة هنتكلم عن Unit 3 First Lesson Distance between two points in the coordinates plane. First, the distance between 2 points on array. Look at this figure. We have point A and point B and the point C. The point A and B and C represented by the numbers 2 and 9 and 12. The distance between the 2 points A and B equal the length of the straight line AB. It's equal the ending point minus the starting point. Equals 9 minus 2 equals 7 centimeter. If we want to find the distance between the 2 points A and C, is determined by the straight line AC that equals the ending point of C, that equals 12, minus the starting point of A, 2, that equals 10 centimeter. The distance between the 2 points B and C equals the ending point of C, 12, and the starting point of B, that's equal 9. The result is 3 centimeter, the distance between point B and point C. The length NM on this ray, M represented by point 10 and N represented by the point 4. So NM equals the ending at M, 10, minus the starting at N, that is point 4, that equals 6 centimeter. After that, we want to find the distance between 2 points on the coordinate plane for the natural number n. Look at this figure. From the opposite figure, we want to determine the point A. The point A is determined by the point 2 and 2. The point B determined by 6 and 2. And the point C, that's on the ray X we move 2 point and we move on Y 6 point. So the point C equals 2 and 6. We want to find the distance between these points. From this figure, find the length between A and B. This distance, as we said, this is equal the ending point minus the starting point. That equals 6 minus 2 equal 4 units. And here we say units because we are on the coordinate plane. And find after that the distance between AC. The ending point of C is 6 and the starting point is 2. So the distance between them equals 6 minus 2 equals 4 units. We want to find the type of the triangle ABC with respect to its sides. Connect this triangle ABC. We find the distance between AB is 4 and the distance between AC is 4. So this type of this triangle is isosceles triangles because we have 2 sides are equal in length. After that, if we want to find the distance between 2 points on a straight line, as we said, the number of the ending point minus the number of the starting point. But we will get it by using the absolute value because on the straight lines we have negative numbers and the distance cannot be determined with negative numbers. For example, on this figure, this line, the point A is determined on -2 and the point B is determined in 5. So the length AB equals B minus A. B is the ending and A is the starting by using the absolute value. So that's equals the absolute value of 5 minus -2. That equals 5 negative and negative that equals positive equal the absolute value of 7 that equals 7 units. If we want after that to determine the length DC, the ray that have DC here on this ray we don't have a point for C. We will determine it here. Say that is C. If we want to get the length of DC, that's equal C minus D. C is determined by 3 minus C equals and D equals -2. That equals 3 plus 2 equals 5 units. After that, the length DE that equals the absolute value of E minus D equals the point of E equals -5 minus E equals -1 equals the absolute value of -5 plus 1 equals -4 absolute value, and the absolute value, as we know, it's giving you a positive number that equals 4 units. After that, if we want to calculate the distance between 2 points in the plane Z, the plane Z contains two rays, ray X that contains positive and negative numbers, and the ray Y dash it contains also negative and positive numbers. And if we want to determine the length between or the distance between 2 points, we get it by the absolute value of the ending point minus the starting point. After that, let us solve some exercise together. Look at exercise number 1. In the opposite coordinate plane, ABCD is a rhombus. Complete the coordinates of the following points. Let us determine the point of A. The point of A equals 3 and 5. The point B is 0 and 1. Point C, we move on X 3 points to left and up 5, so that is equal -3 and 5. The point D equals 0 and 9. The area of the rhombus ABCD can be calculated by using the length of its perpendicular diagonals. As we studied before, the area of the rhombus equal half times D1 times D2, the product of the two diagonals. So we want to get the length of AC, the length of the diagonal AC, that equals the absolute value of negative 3, the point C, minus 3, the point of A, equals the absolute value of negative 6 equal 6 units. The length of BD, the length of the diagonal BD, equal the absolute value of the ending point 9 minus the starting point 1, equals the absolute value of 8 equal 8 units. So the surface area of the rhombus, as we said, we studied in grade 5, the area of the rhombus equal half times the first diagonal times second diagonal, equals half times the first diagonal, we get it 6 AC, and BD equals 8, that equals 24 square unit. Exercise number 2. In the opposite coordinate plane, determine the points in its position. The first point L is negative 1 and 1, negative 1 and 1. This is the point of L. The point M equals 1 and 1, so we move here 1 and up 1. The point N equals 1 and 8. N equals 1 and 8. Here we say M. N equals 1 and 8. Here is N. After that, the last point is negative 1 and 8. Find the perimeter and the area of the shape of LMNH. Here it is E, not H. So we connect LM, N, E. If we want to find the area, this shape is a rectangle, and the rectangle's area equals the product of its dimensions. So we will find the length of LM. LM equals the ending point of M, that's equal 1, minus the starting point L, that equals negative 1, equals the absolute value of 2 equal 2 units. After that, we will find the length of MN. That equals the absolute value of the ending point of N, that's equal 8, minus the starting point of M, equals 1, equals the absolute value of 7, equals 7 units. We here find the 2 dimensions of this shape, and after that we will find the area. The area equals the product of the 2 dimensions, the length times the width. That equals the length 7 times width 2 equals 14 square unit. Here, dear student, we finish explaining this lesson. Thanks for listening and goodbye.